Welcome to the Twitch channel of Manning Publications. My name is Meinte Boersma, and in the next 2 hours I'm going to tell you something about domain-specific languages, which happens to be the topic of the book I'm writing for Manning. The full book title is Domain-Specific Languages Made Easy. Easy is not the same thing maybe as simple, but I'm hoping to make it as easy as possible to get you started in the field. I have a couple of slides, which I'm not going to bore you too much with, so let's get through them quite rapidly. So, this is the book. At least that's the cover of the book. At least it's the picture of the cover of the book with a big MEP, as in Manning Early Access Program sticker on top of it. I'm going to tell more about this book later on. Let's first dive into what we're going to do tonight. So, today's problem is everything starts from a problem. So, as you can see, the title is Domain-Specific Languages, which means we need a domain, and a domain happens to be people making data models. It's bizarrely common. In fact, I just had a very nice workshop or course on the topic of data models by a man named Alex Sharp. Let me get the book. So this is the book. It's about it's a reasonably thick book about domain or data models. It's a very good book as well. The course was also very good, so it got me thinking, let's make a DSL about that. So for the people who tuned in to see something about projecting expressions from an AST, that's not what I'm going to do tonight, unfortunately. I picked a slightly different topic, but we will certainly do things with ASTs. I think it's interesting and should be interesting enough. And in case you want to know more, then you can we can see what we can do another Twitch about that specific topic. So that's the domain. The goal is to have some tooling to input such models, and a solution would be a DSL implementation. So if you want to code along with me, then the setup instructions are in one of my GitHub repos. I'll leave the URL there for a couple of seconds that you can type it over. And then I will show you the plan for what we're going to do today. So we start at the top left box. I'm going to cheat a little bit and show you the end result first. I guess you can compare it to a cooking show where the cook has prepared the end result already and a couple of intermediate steps, so you don't have to wait for the oven to bake for 2 hours and things like that. So it's only slightly cheating, I would say. So after having demoed the Goal app, I'm going to set up the development environment shortly. We'll be using a JavaScript-based development environment based on JavaScript first of all, React, MobX for state management, and Parcel to get the whole thing running on any modern browser. After that, we're first going to create an AST. And once we have an AST, we're going to project it. And by the way, that AST will be deriving basically from the demo app. To project the AST, we'll be using React. Now, then we're left with a nice projection of the AST, but it's not editable yet. So the next thing we'll do is we make the AST editable. And for that, we also need to use mobx to make things observable so that edit actions actually have an influence on the projection of the AST. In order to make that AST editable, I'm also going to introduce something that I like to call edit state. Alright, and then after we did all this AST trickery, we also want to do something with it, and that is generate code. So I'll be making a code generator, a small one for this. And the final thing we're going to do is we're also going to validate this AST a little bit. And after that, I'll have a couple of slides about the book to explain a little bit more about the book, what it's about, what we didn't cover in this Twitch session, and where you can get the book, of course. I will also cheat in the sense that I will have some code prepared, like a television cook. So I might just sometimes copy some code in instead of typing it. Either because I don't remember it verbatim at that moment, or because it's too boring for anyone to watch me type stuff. Okay, the next thing we're going to see later on. So let me switch to the IDE. So if you checked out the setup instructions, in the meanwhile, yeah, apparently we're actually broadcasting. I had to check that as well. So if you checked out the coding or the setup instructions, and so cloned the repo, I followed the other instructions in there, you can use any IDE to open a repo. I happen to be using IntelliJ most of the time because that's what I'm usually using also in a day job. So I'm most familiar with that, and my keyboard shortcuts are in my fingers most of the time. But you can also use things like Visual Studio Code or anything else. In fact, the bundling that we need and that we're using Parcel for runs off any command line interface or off of any terminal. So you can also use Vim if you like. Wouldn't entirely recommend it, but if you really want, you can do that. So let's quickly go through the repository. The main thing is, of course, the source folder that has a pre-baked index.html file with basic necessity. It references an index.jsx file, which has the basic React stuff, one component function, one React component function, which doesn't do anything yet, and then a render function which calls that component function and renders it, and we also include some styling, which we'll not look at because I'm not such a CSS wizard, so I can get things somewhat reasonable looking. But yeah, let's not inspect that too closely at the moment. And earlier I said I was going to demo the Gull app we're going to make in this development environment, so let me do that. So this is the eventual Gull see a couple of things here. There is a section data model, which has subsections entities and relations. Entirely what you would expect for a data model. You could prefer a graphical layout for this. That's entirely possible with this kind of technology as well. But for the moment, I happen to choose a rather simple textual layout. So here you see the entities. Every entity line describes an entity, which is the name here in the greenish box. For every entity, you also give the plural name, so you can talk about singular and plural names in relations. We're going to see that in a moment. And an entity has a kind, and some entities you can derive a certain kind, but other entities you have to indicate whether they are a kernel entity or a reference entity. And you can switch between the two by just clicking on kernel or reference. So if you look beneath the word reference here, you'll see, let me highlight that a little bit. You'll see a ugly greenish color, and that means that this entity happens to be a reference entity. And behind that, there is a text which should hold a description. Well, there's no description yet, so let's put that in. An order. So an order describes a request for a certain product. And no, that's not entirely correct. Let's say for certain products. Order line describes a request for a certain product as part of an order. Okay. You also see some things happening below. We'll get to that in a moment. So, and there's also relations in this data model. So one relation is this one. It's the first one, saying that each order holds one or more order lines. So, and I can change this thing, so I can also say an order line. Should be able to say an order line. It's not working apparently, so that's the first bug. Holds one or more order lines, or at most one order line. Well, that doesn't make so much sense, so let's change that back to one or more order lines. And what you see here is that if I select at most one, the singular name is used, and if I say hold one or more, a plural name is used. So that nicely updates depending on what you put in here in this box. There's also one other thing that, let's say, sneakily updates itself. That's, if you look here at the word an, because in English it's an order. But if we're talking about a product order, for example, then it should be a, and that nicely updates that as well. So I want to emphasize that because today we're creating a domain-specific language, and if you're somewhat familiar with the topic or heard about it, you also probably heard about things like parsing and such. And that's something we're not going to do today because we're using a completely different paradigm from parsing. So this is not a textual DSL. It looks like text, but it doesn't look like the kind of text you would have in an IDE, for example. So this is really nice, nice text which you would find in a real web app, and not just a box of monospace text. So that has certain advantages. The first example is that it looks nice. because you can apply all kinds of styling. This goes also a little bit beyond syntax highlighting. You can do a lot with syntax highlighting, but with projectional editing, as it's called, you can do a lot more and have a lot more influence on the visualization based on your DSL content. Oh yeah, the rest of the Go app, there's also a box generated code down here, so that already has the generator working. Also here you see this is a very simple textual output. I could also have made a SQL table definition here. Maybe we'll change that. We'll see. If people request that, then I can also do a SQL generation there. No problem at all. And also there you can see that as soon as something changes here in the DSL content here in the data model, then it updates immediately in the generated code here. Okay, so let me get back to the development environment. So I'll switch to my IDE again. So let's look at the index.jsx, and oh yeah, the way we run this, that's using I happen to be using Yarn, but you can also use npm for running stuff. And in fact, we don't need Yarn so much. We can also just use the actual command. Apart from that needs npx in front of it. So now the parcel bundler is taking the contents of the source. And of course, I took the wrong thing. Contents of the source. Builds that, starts up a web server, and also watches this code. So whenever I change something in the code, the parcel bundler detects those changes, picks them up, rebuilds the whole thing, and also sends a signal to my browser that things have changed and that it should reload, which it then does. This is very convenient. So let me go to the browser. So this is the Go application, so I'll now switch to the real one, and that says do stuff, which is not much yet. For now I'll switch back to the Go implementation, because the first thing we're going to do is not make a projection, but make an AST, a so-called AST. So let me explain a little bit more about ASTs. AST stands for Abstract Syntax Tree. Let me write that down. Yeah. So an AST stands for Abstract Syntax Tree. I don't know how much to explain about that. Maybe the most important thing is we rarely see ASTs in the flesh, as it were. So if you, for example, would do parsing, so you would make a parsed DSL using a parser that parses plain text into an AST, you would still not see the AST so much, because in that context the AST is very much an intermediate product, and the actual DSL content is formed by the text in the in a text editor. So basically the plain text, the stream of characters, that's your base DSL content. And then a parser turns that into an AST under the hood, as it were. And then all kinds of things happen with that AST, but you rarely see that AST in the flesh in real life. That's different for projectional editing, where you really turn it around and start from the AST. And you still might not see the AST so much concretely. Well, yeah, it is an abstract syntax tree, so it ought to be abstract, but it's very explicit in your code, and you really drive the entire projection with the AST. And in this case, we're going to be deriving an AST from the demo content that we have, and coding that up directly into code. Of course, that's a bit of the difficult thing with abstract things, is that they ought to be abstract, and as soon as you write them down, they're not abstract anymore, but concrete. But yeah, at one point you have to put stuff into the computer, into code. Otherwise, we're not going to be able to do anything with it. Yeah, I'll be drawing a little bit of a picture later on. Funnily enough, the family was watching Inside Out, the movie Inside Out today, and there's a very funny bit about abstract thought in there, which is very, very advanced for a kids movie, actually. It was funny to watch that again. Can recommend that to everyone, certainly with kids. Okay, so let's go back to no, we're already at the right spot, because the first thing we're going to be doing is deriving some information from this projection. So we're basically reverse engineering the goal app and derive an AST out of that. So let's first look at things we can recognize. And one of the things that are easily recognizable are entities. So here we have an entity. Let me highlight the thing entirely. So what does an entity have? Well, first of all, it's called an entity. So I'm going to be writing some stuff on. I don't have a second camera to show you this, but I'll hold up the stuff. So we have one entity, and this thing has a singular name, which is order, and a plural name, which is orders, and a description. So I filled it out earlier to have some text, but I'll revert that to the empty value again. So if I were to write that information down, then it would look like this. So this is the first entity, which is a box with a label entity, and then a singular name, which I abbreviated as SN, and with order, and a plural name, which I abbreviated as PN, with orders, and then a description, which I abbreviated as DESE, with, well, empty, basically. So we have a second entity as well. Oh, this is going to be such a messy picture. So, same thing. Entity, which is a box, and the singular and plural names, and the description. Okay, so that takes care of the entities. The kind part we're going to get to later on, hopefully. So next up are the relations. Every relation has... well, am I going to draw that? Yeah. So a relation has a phrase, which is the piece of text there. So for the first one, it's holds. And anything has a cardinality, which is one or more. And now the nice thing is this relation refers to entities. So instead of having to spell out in the relation box, so let me first show what I drew up. I have a box with relation as the label, the phrase holds, and a cardinality at least one, or one or more. So, but now we have to still put the information about the references to the orders in, and these are really references because I can only choose one of the entities I have here. So I think I call this one, oh yeah, left and right. So the first thing is the left entity reference, and the second one is the right entity reference. So I'll draw those in as, and you'll see that in a moment, as references, which I can label as left and right. So here we have that. So this is a reference from the relation box going over the relation called left, and it's going to the order entity. And the second reference relation, second reference is going from this relation box over the right property to the second entity called order line. So let's also put the second relation in. So there the phrase is belongs to. Cardinality is 1 because every order line belongs to exactly one order, which makes sense. So I'm also going to draw in the relations right away. So we end up with this. So same thing. I made some cartouches for the relation names, or for the reference type names, so you can see these are both the right and left, and that's not right because I have to switch them around. This is going to be messy. Now this one is going like that. And this one is going. Okay, no one's going to be able to read this anymore, but we'll get to that in code later on. So this doesn't look like a tree at all. So we have to make it like a tree. Oh yeah, now trees are shaped, of course, as usual, upside down. So let me quickly draw an upside down tree. So here we have an upside down tree. Of course, everything in computers is upside down trees. And now let's make a actual tree of our DSL content. And the way I'm going to do that, I'm going to put a data model box on top of it. And basically, its only purpose in life is to have children it's not a very nice tree, it's a very mangled tree. So we saw one type of relations so far, which is the reference relation, which goes from one box or one object in the AST diagram to another one. We'll see now the other kind, which is the parent-child or containment relation. So here we have the data model, AST object. I like to call these objects these boxes. You can also call them nodes, whatever you want, but I have to choose one word and I choose object. And the entities are the children of this data model object through the entities relation, and the relation AST objects are the children of the data model object through the relations property. It's all very very straightforward, I hope. So now that we have drawn that, let's make some code for that, because now we have this diagram and we can make some actual code for that. So let me go to the IDE, and I'm going to create a new file, which is example ast.js. Yes, I guess I want to add that to Git. So, and the funny thing, of course, with this diagram is now we have to, it makes sense to for each object in this diagram to make an object, but we have to be a little bit careful about the order in which we make these objects. So I first start with the entity objects. I hope this is, I guess this is readable. So first I make a JavaScript object for the first entity. Let's call it entity. What did I call it in the... Sorry, I have to... No, I called it order. I have to cheat a little bit here. So, and an order, well, we know it has a concept, which happens to be entity. And it has some values for its properties, and I put it on a separate sub-object which I call settings. So we have a singular name, which is order, and we have a plural name, which is orders. Okay, so all fine. So we also have the entity order line, which I put in a constant called order line. It also has a concept. Also has settings. It has a singular name, which is order line. It has a plural name, which is order lines. Okay, so all good. Well, next up, we want to have a relation. So these things I am going to call relation 1 and relation 2 apparently. No worries. So the concept we had here was a relation. This is a little bit ugly. So one thing that I would like to do is I create a separate file which is called concepts. And in that I define this one. I will copy paste. Ooh, I'm giving away, I'm spoilering a little bit here. So I define some constants with the names of the concepts, and I put them into constants which have the same name as their contents. So basically this is like a cheap JavaScript enumeration. And instead of using these strings here, I can now just import these things. So I will import, I guess I will in the end import everything, but for now I will import entity and relation. I can just remove these things. And this makes it a tiny bit safer. Okay, so also a relation object will have a settings sub object. And it will have a left or left hand, apparently I call it. And now we want to point to order. But this is problematic in practice because this is a JavaScript object reference. But in JavaScript, you cannot really distinguish between objects which you are containing or objects which you are referencing, but because basically you're always just referencing things. And they exist somewhere else, and you can reference them through a object reference. But we also need to know whether something is an actual reference in the sense of our AST, whether there is a dotted line here, or whether we have a solid line here. So we need to use a little trick, and the trick I use is that I put this into a subject sub-object itself, which happens to have only one property with key, ref, and then the order. So the way this works, in the way you can use it, is that if you encounter an object somewhere, then you can always recognize it's whether it's an AST object, because it will have a concept key value pair, a settings key value pair, and basically nothing else. And as soon as you encounter a setting which is an object, such as this one, you will know, or you can distinguish, or you can tell which type it is, whether it's a reference or a parent-child or a containment relation, by looking at whether it has just a ref key value pair, in which case it's definitely a reference. And if it's of this shape, so it is an object and it has a concept property and a settings property, then you will know it's an actual AST object, which is a child of the enclosing object. So in this case, we know it's a reference because here we have ref. Okay, so let's also do right hand, same way. And there we reference order line. And we have a couple of other settings to do because we have a phrase. And the phrase is holds. And the cardinality is 1 or more. You could also make some cheap JavaScript enums for these kinds of things because they are enums as well. In fact, we could even put the property names in cheap enums, but let's not do that right now. Okay, so we also have a second relation. Again, it really is a relation. It has a left hand, and the rest I will copy. Not because I'm lazy. Well, I am. but also because we might run out of time otherwise. So now we have 4 of the boxes in this diagram, but we need a 5th one, which is the data model thing. So let's make that one as well. So another const, which is again an AST object. Oh yeah, I guess I need the data model constant here. So, and it has settings. And one of the properties is entities, which is an array consisting of order and order line. And we also have relations, which I also put in an array, and it's relation 1 and relation 2. So we see here that order was important, because basically you need to wire this up from first start with things which have no dependencies on other objects, and then you go to the things which are dependent on that. So for example the relations, and then finally you end up with stuff that is dependent on basically everything else. In case you have cycles, it's a bit different thing, but we're not worrying about that today. So now we have an AST. Great. Now let me very quickly go back to the plan. This was the plan. Where are we in the plan? So we are in the plan here at, we did the creation of the AST, so now we're going to the projection of the AST. So we have to change something here in app. And what we have to change is, for sure, we need to import the example AST. So, by the way, the idiom of JavaScript I'm using is, I guess it's ES 2016. Yeah, it's probably 2016 with everything that we'll be using. So Parcel takes care of compiling this down to a JavaScript idiom or JavaScript source that is actually runnable by most modern browsers without problem. So if you look at the stuff that the JavaScript code that Parcel generates, it looks quite different from this. So one of the things it does, for example, it at least I guess, is that these kind of const arrow function declaration, Parcel turns those into old-fashioned function declarations, which work just as well. But I happen to like this syntax a lot better than the function syntax, although we have to use the other one as well sometimes. So, yeah, let's do stuff. I'll create a new file which I call projection.jsx. I will also import React stuff into that, and we're going to make a React component. Keep forgetting that syntax. So we will pass it a value. It sounds a bit more general than just an object. In practice, it will be an object. But yeah, this is part of a more general pattern, which is the depth first tree traversal, which is very useful for going through ASTs in a very organized manner, and I happen to be using that pattern in the book. So this thing happens to be a depth first tree traversal as well, essentially. So that's why I take this use this code pattern, and that's why we are calling this a value instead of something else. And the way we're going to call that is, well, change this app a little bit. So what we'll do there is I'm going to make a div, and we're going to call this projection. So it gets auto-added. Oh yeah, one of the things that Parcel does is it adds semicolons. Obviously I have to put in these semicolons, but I really hate semicolons. So I'm not going to do them. Parcel puts them in, and usually the whole parsing is just fine. So I'm not bothering with them. So this projection component, which we now imported through this thing, this import statement, it receives one value, and we put in the example AST, and then it should just project. So let's return something here. I had an idea for that. This is that, which I'm just going to copy in. Namely that right now for everything we put in there, it will just return a text that there's nothing defined for this specific value. Okay, so if I save this, it will run this, and I have to go to the actual, and indeed we see, oh, there's no projection defined for value object. Great. Exactly what we expected, in fact. So let's change that. We go back to the code. And the first thing that seems to be healthy is that we're going to check whether this thing is actually an AST object. Because if it's not, then yeah, don't know what we're going to do with that yet, but we'll see. That also means that we somehow have to recognize whether this is the thing we put in there is an actual AST object. I'm going to copy a little bit of code for that. We don't need to export here just yet. So the first thing I copied in is a function which checks whether some value is a JavaScript object, a real object, and not an array object. And the second function uses that one to check whether it's a value is really a JavaScript object and not an array or a string. And it also checks whether concept is in value and settings is in value. That's the only thing it does. So if that is the case, then we know we have an AST object. Great. So what can we do? In this case, well, we can switch on the concept, because we know here we can also use data model. So the first thing we might want to do is do something for data model, because that was the outermost or the root of the AST. So that's the first thing we're going to encounter, because that's what we're actually putting in. If we go back to example AST here, this is the example AST. It's indeed a data model. That's what we're exporting. That's what we're importing here again, and that's what we're putting into this projection thing. So now we go back to projection and do something here, and let's make a div with h3 in it, and then we have another div, and we have some no, we have some entities in there. I happen to have made some styling for this, so I will just put this in. So this will take care of some indentation and such. And the next trick I'm going to be using is some destructuring. So we know that value is right now a JavaScript object which has a concept, but it also has settings, and I want to destructure these settings. So I do this in case you never have seen this. This is called destructuring. So essentially it does exactly the same thing as this. And in fact, IntelliJ recognizes that. So, but I like this syntax much better, and we're in fact also using it here because this is also destructuring. So now we have a settings constant which we can access directly, and we know it will have an entities entry, which is an array. So we're going to map over it. This is again a JavaScript arrow function. So we take the entities out of that, and we also use the index. And now we're going to do a funny thing because we're going to be calling projection again. And obviously, is it obvious? Maybe not. So we're going to pass this projection thing for value entity, and we also have to pass the index into a key attribute because React demands that we do that. So let's have a look at the results. Okay, that's a bit better. So we now see that we have indeed a data model thing, an entities title, and then 2 times the no projection defined for value object. Great. Well, that's indeed where we want it to be. Now let me get back to the IDE scene. So now we know we can, oh yeah, let me also add a default case here. Oh, this is just fall through, so it will just fall through to this thing, which is fine. So, our case is entity. So in this case, we'll return a div, and in the div we'll have a couple of things which I'm also for time reason just going to copy in. So first we have the indefinite, so the a or the n, and that's I call it a keyword. That's, or I give it a style keyword. It's a bit of a flashback to the parsing days, I guess, in some sense. So that has to inspect the singular name and the well, let's do the singular name first. It's maybe a bit easier. And also so singular name, that should appear. Then we have some other semi-crap which I'm going to copy here and copy in. I don't know where you are, but for me it's almost 9 o'clock in the evening, so I'm starting to run on fumes at the moment. And that's why, might explain why sometimes a little bit of Dutch creeps in. So plural name, then we have to close that with, yeah, I'm not going to put everything in. Oh yeah, describes, the kind I will put in later or not at all, depending on how far we get. So span, and then we have the description, and finally we can just copy this line. We'll have a dot. Okay, let's see what things look like now. So actually this does not look what we want at all yet, but we'll get there in the end. So we're missing the A or N. For that I'm going to cheat a little again. I will create a file called textutils. And we'll copy those in. So these are some JavaScript functions that one is the function to turn the first character of a word into, or first character of a string into an uppercase character, and the other one is given a next word like order or order line, it will determine whether you need an A or an N, and it does some. It uses a regular expression for that. This does not fail safe because English is a weird language. But anyway, as soon as it starts with a, what is it, consonant? Yeah. As long as the next word starts with a consonant, the N will get added, and otherwise nothing will get. Don't see that here in code. Put it here. So nothing will get added if it starts with a vowel, or the other way around. Anyway, this works. So I'll put it into projection. So I want to have with first, exactly. And we need a singular name for that. Oh wait, that's why it wasn't working. So now it gives me some content assists. Now it understands what I want to do. Because I have to put it in these curly braces in React, of course. If we now go to the oh, sorry. I've been showing you nothing at all. I've been showing you only browser stuff. My apologies. So what we added was these functions, which I talked about, which turns, the second one turns the first character into an uppercase character, and the first one determines whether you need A or N. And I'm using those here, and what it looks like then is, so indeed you say N, and this already changes because let me now sneakily adjust the AST. So if I turn order into product order, we'll actually see a product order instead of N. So that works. Let me very quickly also do the relations, because we haven't done anything for the relations yet. And don't worry, these things are not editable yet, but we'll get to that. I'll just now try to get to a state where I can start copying in stuff as quickly as possible. So this works the same way as the other one, so let me just copy in stuff. I don't need that yet. Am I showing you this? No, I'm not showing you this. Now I'm showing you this. So I sneakily copied in this stuff, so now also the relations get added to the data model, which means that if we go to the browser, we actually see no projection defined for, which is completely correct because we still have to do that. So now we can do a relation. Yeah. Again, I'll just copy in stuff for the moment. Yeah. I'm still not showing you the IDE. Yeah. So here. So this was. Excuse me. I was building the relation. So this I just put in. We have to. So now we have to look at relation. So we're getting, in this case, because we check for concept relation, we're getting something of this shape. So for example, this one, which means we're looking at settings, and then we want to look at left hand, and we want to look at ref. So that means that in this case, settings, left hand, and we know this is a ref. So now this thing, from here on, we're pointing to order. So this is an object, AST object, which again has a settings. So, and we want to get to the singular name. So that means that here I have to go to settings again and then singular name. Great. So that takes care of each, and then the left hand entity. Yeah. So then we're going to add in the phrase. Put some non-breaking spaces. I know it's not official HTML, but right now I don't care so much. And then we have the second entity, entity reference. So I'm just going to copy this stuff in and replace left hand by right. But this is not correct either. This is not correct. We'll see. Because first of all, we have to add in the cardinality as well. So let's add in that one as well. And here we have to add in settings. Now we have to use cardinality. So if we now go to the browser, we see that it already reads each order holds one or more order line. That's not correct. So we have to pick here not always the singular name, but the singular or the plural name depending on which cardinality we have. So we do a little trick here, because here, this is in the end, this syntax, it takes a string on the inside. So as long as we produce a string as an expression here, it will be fine. So we just have to return either singular or plural name. So we can now let's use if this cardinality ends with more, it should be a plural and otherwise it should be a singular. So let me do it like this. So in this case we need a plural name, and otherwise we need a singular name, and we just do it like that, and that should sorry, not showing the right window again. Yeah, so the code I was creating just now, let me add in some completely unnecessary white space. So yeah, so instead of always having the singular name here, we need a plural name or singular name depending on whether cardinality ends with more. In case of more, we should take the plural name, and in case of not more, we should just use the singular name. So we do that, ternary expression here, and then we put name behind it. And if we do that and we run that, let me get rid of that thing as well, because we know it runs. And we now go to the browser window, and then we see, oh yeah, one or more order lines. Great. So okay, let me sneakily put a dot behind that as well. So we rendered, and now indeed we have a dot there. Okay. So now we rendered the AST. There are some styling issues, but those will get resolved in quite short order. So, but this is not editable, and that's a pity, because we would expect, certainly already knowing and having seen this goal, we would expect to be able to edit this. So click on it, see that it's editable, click on it, change it, and then things should change along as well. That's not the case yet, so we have to make this editable. And the way I like to do that is make use of something called edit state. And I'm now going back to the slides for a second there, just to show you what I mean. So this is the architecture for projectional editing, for a projectional editor. So I hope you see a box AST there. So what happens, what we've done so far is we have an AST and we project that. So a projection is basically a React component function which takes the AST or a component or an object inside that AST and then produces some HTML DOM using the React JSX syntax in this case. So as soon as you have an HTML DOM, that also means that you can listen to events like mouse events or keyboard events. We're going to be doing that in a second. So this HTML DOM essentially fires events, and that triggers actions. Those actions might be change the name of this setting to a different one. We want to change order in product order, for example. So these actions change the AST. So we go back from the actions box over the change transition line to the bigger box, which is labeled editor state. So there the AST is edited. But in order to know that something is being edited, and in order to know how that something can change the AST, we use something which I call edit state. And that's an object which holds some information like the current value, like whether it's being edited right now, and how to change the AST. And that object you can pass around to other React components, which, for example, render a text, and when you click on it, it goes into edit mode. and then it will render a input text box instead. And when you close that, for example, by pressing enter or by pressing tab, it will change the value in the AST. So we're going to be doing that right now. So I'm going to be copying quite a bit here. So let me go. Let's recap that a tiny little bit. So this is what happens here. So we called the projection function. We put in a value which is an AST object. In this case, it's labeled with concept something else, and it has a bar name. Where you want to edit this name bar, and then that value gets copied to this edit state object in the value property, and it also has an inEdit property which is either false or true, and that thing gets passed off to a text value component, which will do the right thing depending on the value of inEdit. So that's what we're going to do now. And for time reasons, I'm going to be copying in the React components. Let me see whether this works. No, that does not work. So this is, of course, cheating quite a bit. The most important thing here is that you see a exported constant called text value, which receives an edit state object and which inspects the inEdit property on that. And if it's inEdit, it will render an input box, and when it doesn't, it will render another component which happens to be a display value, and that display value component will basically do the same thing. It does a little bit more, but that's not so important right now. I could also just replace this with let's do that. I could also just say span. Class name is value. Let's state that value. And we have to add an so-called on click. I think through that. So that renders okay, or that builds okay, but of course we didn't use this thing yet, so now we want to use this thing on singular name here, which also means that we have to create an edit state object, which I will do cheatingly as well, because what I will do is I make a function which creates an edit state object. So this is a function, it takes a property name, and I will throw some stuff away which I will add later. Oh, this needs to go around still. So this function takes a property name and it creates an object, hence this syntax, which has as value the value for that property from the settings, and it will say inEdit is false. So for example, for the singular name, instead of doing this span here, I can now say text value, which will get imported here. And then I will pass it an edit state object. I create this edit state object for the singular name property. So now I can remove this and let's have a look at what we see here, and lo and behold, we have an editable, well, almost editable. It's not entirely editable yet. We'll get to that in a bit. At least it looks more editable, so that's good. There's one more thing missing to make it truly editable, and that is, so first of all, I would have expected if you click this that somehow this thing would go into edit mode. So going back to the code, because after all, this text value thing rendered a span with the name of the entity, and then when you click this thing through the onClick handler, the inEdit property was set to true, so you would expect that this thing would re-render itself and then go into input mode. But that's not entirely the case yet, because the edit state object is not observable yet. And that's where this mobx thing comes in. So let me go very quickly back to the slides. That's yeah. So we said that we're going to use mobx, the mobx framework, at some point, and mobx is a framework to do reactive programming, or the official word is transparent functional reactive programming. The other word that you can use here is state management. So what it does is you can make stuff observable, and then you get a something back that looks like the same object that you put in it. But now, as soon as something changes on that object, it will notify observers, and observers are objects that subscribe to a certain observable object. And one of the typical kind of observers here is the React components. So we will sprinkle some words observable and observer onto various things, and then magic starts to happen, and this edit state will work. Okay, so let me go back. So we already see here observer, so this is going to be an observer. It's all very nice. And we also need to make this thing an observer, and we do that by just wrapping the entire function in with a function called observer. We have to. So what this observer function does, it takes a function, because that's what you put in it, and it registers this function as an observer. So now whenever a value, assuming that value is observable, whenever it changes in some way, then the observer part will decide whether it needs to re-render. Of course, we also have to put an observable thing in it, so let's make the example AST observable. Semicolon be gone. And then does this work already? I guess it should. Let's go to the browser and see whether it does something. It does nothing yet. Let's see what I forgot to copy in. Oh yeah, I have an idea. So if we look at the, this is, yeah, so that's what I took out before. The edit state itself should be observable as well. So now when we click on order, it will actually change into an input box. And we can, and this of course doesn't work yet either, because that's what we commented out, or at least exchanged. So I will put that that in, and then the enter functionality works. We'll run through that really quickly. But at least you see that you can click this stuff and then it gets in edit mode, which is fine. So now let me switch. Where were we? This. Yeah, so if we put the original thing in, and we go back to the browser, then it will actually not work, as usual with these kinds of things. So let's see what I forgot there. Yeah, of course. As soon as you see an input box, I have to go back to the live scene. As soon as you see an input box, then well, as soon as you try to leave it, for example by pressing enter, it will detect that through the unkeyUp keyboard event handler. It sees the enter, it will think, okay, let's use this new value. Then you still have to update this value in the AST. And for that, it expects a set value property on the edit state object. And when I say expects, that's because we made that agreement with ourselves. And it's also what I took out earlier. So this is a function that knows how to change the value that the edit state object was for to the new value, to this new value. So let's put that thing back in. So we'll go to the projection function, and then we add this set value function, which is given a function, given the new value, it will update the value of that property in the settings sub-object to the new value. So if we put this in now, it should work. Famous last words. And indeed it works. Okay, something that does not work yet is this does not get updated yet, but we'll get to that as well. So let me, also for time reasons, let me cheat in a big way, and I will basically finish the editable projection for everything in one go by just copying that stuff in. There. Cheating in a big way. I have to also cheat in a slightly different way, because one of the things I did not do yet was put these textual functions into a separate file. Did we already put them? Yeah, we put them in there. Yeah, no, I did that already. So that's good. But no, one other thing I did not do yet was I did not put the AST related functions in a separate file. So I'm going to make a separate file for that, and also copy those in. And in fact, for time reasons, I will also cheat in another function, which is a function that creates a new AST object. It's a very simple function. So what I did here was I just copied in the complete projection. A lot of this you can already recognize, like this. This is still the same. But for example, more stuff was added here in the relation to be able to reference an entity. So this is a separate component which takes care of rendering the entity references. So, and it will also use a text value component, and it will also use a drop-down value component, so we can actually make drop-downs. So this is basically good old-fashioned web development React stuff, but specialized in the sense that you're depth first tree traversing through an AST and allowing the user of the app to change that AST directly from the application. So let's have a look at whether this builds or whether we forgot something. Yeah, we forgot a I will just put that in as well. I have to run, for time reasons, I have to run through that anyway. You will find all this code in the repository. So the repository has a couple of branches. Main, which has only the README and the license text. The branch Twitch goal, which is what we're working towards to now. And full implementation, which is basically an even more extended version of that. So what I have in the oven is the Twitch goal branch, which has all the features that I would like to show already in. So does this finally work, or did I still forget something? I still forgot something. Oh yeah, more oven stuff. Yeah, so what? In one of these files, I compute the kind or the type of this function. Let's see whether it works now. Yeah, now it works. I can go to the browser and see what it looks like there. Yeah, so that looks not too bad. So we're already well, screen-wise halfway there. This works. You can change things. This works. All fine. Can reload the thing. What we don't have yet is the generation. So you saw in the demo thing that here there was a lot of generated code, and we want to do that as well. So let's make that happen. So for that, let's first create a generator which exports a, let's call this generate, and it takes an AST or data model, I guess, because we want that, we don't want that. So it takes a data model and it generates some text, because that's what generation does. So some text. If you're not familiar with this, these are the ES 2016 template strings, JavaScript template strings, very convenient for text generating text. So the syntax is a backtick and then text, and you can put stuff, expression between dollar curly brackets. And we're going to be using that to actually generate stuff, actually text width. But first let's hook this up to the application as a whole. So go to the index. Here we want some header, and then I set up a style for a pre, and we want to generate, and I'm going to do something here, which is this. I'm going to put in a separate constant, which I can pass along, then I don't have to make it observable twice. Yeah, so let's run this, and then we already, yeah, so okay, so it generated this some text just fine, which is fine and fun, but not so useful yet. So let's actually do something with the entities. Okay, no one is clamoring for SQL yet, but I'm going to do that anyway. So what I'm going to do is okay, so also here I'm going to use slightly different. I'm going to do some destructuring again, because I happen to like destructuring. So I'm going to run over the entities in the data model, and for every one of them we want to be let's say generating a table, because that's what you typically do with entities. You create a table definition for that. So that's a function declaration, so I can yeah, I can just map the entire function. So this gives me a bunch of text, which I will join with 2 new lines between them, and then I can say create table so here an entity, have the entity dot settings, and then we use the singular name for this, and we can say things like yeah, maybe we want to, what's how is SQL syntax again? Well, let's not bother with that too much. So let's first see whether this works. Go to the browser again, it crashes for some reason. Let's find out what's going on there. So what you're seeing now is the interesting. Yeah, what you're seeing now is the developer tools. In this case, I happen to be using Firefox, which is fine, so I can put a breakpoint on it and run it and see what is going on there. So in this case, yeah, the fun thing with these observable objects is that you basically only see proxies, like here. So I have to interact with it a little bit to see whether it has the things I would expect it to have. So it does have entities. Okay, so what is then causing the problem here. No, this is the same one. That's a bit weird. Yeah, I'll cheat a little bit. Let's do it this way, see whether that works. Now entities is okay. Let's go back to the index function. Now we probably, well, when we say we, I of course mean me. That should work. That should also work. Yeah, we're actually seeing this. Okay, so if I want to see pick time, then I just copy in the original thing. Let's see whether that works. And that also does not work. Yeah, so as you can see, that also doesn't work, but it's because I used different names. So what do you mean it's not a function? Of course it's a function. It actually returns stuff. So the browser is still giving me errors which I don't entirely understand. Let me quickly rerun partial to see whether there's not something there. Some stale state going on. After all, this is old-fashioned web development for the most part, so we also will have the same kind of problems that we normally have. Great, always fun this. Of course, it should be something really small that I'm just not seeing right now. I would propose to get back to this in a very short while to see what's going on. In the meanwhile, so I'll probably find out what I forgot in the next couple of moments. So let me fix that in the last couple of minutes of this stream. All right, now let me go back to the presentation. So I want to talk a little bit about the book while I'm trying to figure out concurrently what was going wrong. So the book is an introduction to domain-specific languages. It's really an introduction. It doesn't assume anything, or not much at least. So normally you would see things or encounter things like language engineering, abstract syntax trees, code generation, compiler construction, things like that in a computer science course. But my experience is that most soft dev, or at least quite a significant part of them, do not actually have not had a computer science education as much. They just rolled into the field, taught themselves to do programming, and went from there. And that's all fine. But it does mean that you will probably not have seen an abstract syntax tree in real life so much, or any of the other things that make up the field of language engineering. So, and it's a pity because I think that domain-specific languages can benefit a lot of people, and not just computer science people, but developers in general, and especially the people that you have to develop software for. So what I regularly see is that software developers creating an application, a software system for a certain domain, and people in that domain, the so-called domain experts, are actually very smart people. So smart, in fact, that usually they can sort of program with Excel. I often joke that the most often used programming environment is Excel or some kind of spreadsheet program, and I continue to stand by that because a lot of smart stuff gets done in Excel. But Excel is not a software system in itself, so you need to figure out a way around that. So you need to give the domain experts the tools to be able to encode write down all their business knowledge into a format which they can understand. And that format has to be such that you can also generate a software system with. So that's what you do with the DSL. You give the DSL to domain experts, like data modelers in our case. They will create in this case, a data model out of that. And then using a generator, you will generate code from that. And a DSL has to be precise enough that you can actually generate software with that. But it must also be readable for the domain experts. So it's really a kind of a best of both worlds situation here, if you apply this correctly. So that's why I wanted to write an introductory level book for DSLs, not assuming anything in the way of language engineering, but really explaining everything from the basics, like abstract syntax trees, like how you do this projection, etc., how you do validation, that kind of stuff. So you can actually create DSLs yourself. Whether you do this really from the ground up, from scratch, is not so, in real life is not so important because you really need to have all these concepts and notions like abstract syntax trees and projection, validation, code generation, type systems, etc. Down in order to be able to use other pieces of software which are called language workbenches, with which you can create DSLs quite a bit quicker than from scratch. So, but the book assumes nothing. The book also doesn't use anything specifically language engineering-y. So no language workbench, just pretty plain vanilla JavaScript, and uses React and a sprinkling of MobX to achieve its goals. So what the book also does, it focuses exclusively on projectional editing on the web. So the web part is being taken care of through React. And the paradigm which we've been using to do this projection is to not do parsing. Basically, is projectional editing. So if we go back to this architecture, we really start at the AST. We project a nice HTML DOM from that. We react to events fired from that HTML DOM, like I want to change this input, or I want to change this thing. I want to add something here. And then the AST gets changed. So the AST is really front and center. It's nicely visualized for you, and you can change it as you like in terms of that visualization. Yeah, I already said that the technology stack I'm using in the book is really a mainstream or vanilla type of JavaScript with some well-known frameworks. Mobix is I guess by now also pretty well known, and React is very well known. And one thing I also do in the book is I pay special attention to business rules. Haven't shown anything from that yet, but business rules. So things like given a certain situation, when the following condition is true, then this and this should happen. It's a specific form of business knowledge which is very often occurring. So we pay special attention to that to allow you to put in that kind of form of business knowledge and put that in front of your domain experts to to type up, basically. So where and how and when to get it. There is a product page. We can also search for domain-specific languages on Manning.com, and I guess this book will be the first hit. There is a discount code which you can use for this book and for, in fact, for all of Manning's products. The discount code is, see this highlighted? Yeah, so it's TWIT BOER14, which I guess stands for Twitch, and Boersma, which is my surname. I have no idea where the 14 is coming from. Doesn't really matter so much, I guess. So you can use that to buy the book with 40% discount for in both the ebook and in the physical, so the p-book form. You can also have a look at the contents in the live book version. So that's the second URL here. Also there you can, you can just visit this through the product page. So the book is in MEEP, the early access program. The first 6 chapters are published. Working hard on chapter 7 is already mostly done. Working hard on chapter 8. And the print version and the complete ebook should be available in spring 2021. The more copies you buy now through MEEP, the better a chance that this will actually happen. So there's a lot of things in the book that was not covered in this session obviously, because we can do only so many things. So things that are obviously missing from this session was adding objects we didn't do. Also selecting and deleting things we didn't do. The AST was just constructed in memory and shown from there without actually being stored in a database or on disk or somewhere. That's covered in the book. Expressions is very interesting, but I also didn't get any chance to cover this now. So business rules we'll be covering, type systems, and more in general, how you would design a DSL and how you would evolve it. You can have a look at the table of contents on the product page if in case you want to see more. But let me try to get back to the code and maybe figure out what is going wrong there in the remaining 8 minutes. I'm really very curious. So I'm just going to put some good old-fashioned print statements in there in order to see that is not am I exporting? No, I am exporting that. No, this is not a function. Generate from generator. How is that not a? How is that not a function? One thing I would have to do is, which I indeed did not do, is make this entire thing an observer, so it actually listens to the AST. And then I also have to import that. Yeah, this is very interesting, and also very frustrating, obviously. Cannot resolve. Wait. Yeah, that's what you get when you copy stuff. Yeah, that looks more like it. So there we have our code, which also changes if you change things here because of the observable nature of things. It will also change in the generated version of that. So that's all. So I put here in the usual foo and bar stuff. You will actually see that change as well. And well, I didn't even show this, but if you add an entity, it will also into threes. It will also change there. So exactly what you expect, and then you can also add a relation there, and it will crash majestically. So the one thing I would like to show you now is some validation, because you can put in stuff that's obviously not right. For example, if you put in two entities with the same name, then you should get some kind of error saying that this is probably not what you meant. So that's already happening here. That's because I copied in the stuff. So what you see here is the order line input is flagged with some kind of semi-wiggly line there, and it has a tooltip, very old-fashioned tooltip, which says should read another entity with the same singular name already exists. So let's fix that misspelling or that forgotten word, and I can show you what's going on there as well. So if we look at the projection and we go to entity, where is entity? So yeah. So here we see the text value component call, which renders the singular name and gives you the possibility to actually edit that. Also a placeholder text name, which you see when you create a new entity and the singular name property has not been filled out yet. Around that there is a issue span wrapper, which is it's another component which you pass all the issues for that are generated for this AST object and the name of the property, and it will figure out which issues are specifically for this property, and then it will show you that in that way. But it also means that we have to calculate what issues there are. So where does this issues variable come from? Well, that's a result of calling the validate function for this thing. So if I go there, this is again a tapped first tree traversal. So given any value and all of the AST objects that are containing this AST object or this value. So at first it will check whether it is actually an AST object. It will do the usual destructuring, and then it will switch on the concept, and I only define stuff for the entity. I will build up an issues array, and then I will check among all the entities. So that's this expression, and this data model function takes care of fishing out the data model root from all the ancestors, which is basically always the first one. This is what you see here. We'll just take all the ancestors or yeah, actually it's the last one because I passed them in reverse order. That's something I could not cover or not explain properly yet. But so it goes through all the entities, and if some other entity, which is not the same as the entity we're looking at right now, so it will check whether it's not the same thing. If that other entity has a singular name, which happens to be the same as our current singular name or the singular name of the current entity, then we will generate a issue, and we will push an issue to this issues array with the singular name property to indicate what the issue is about, and then a message. In this case, we will want to add another entity. Let's also change it here. So, and this issue span wrapper will find out what's going on. So let's check whether it now does the right thing. Let's change the name again, and indeed now it says another entity with the same singular name already exists. Okay. Well, yeah, that's everything I wanted to show right now. It's also 4 o'clock EST or 10 o'clock my local time. So it's time to sign off. Thank you for watching this this channel and this session. I hope you learned something, and maybe I'll be doing another one again. So for now, thank you for your attention, and see you. Stay safe. Bye bye.